Alright, in this video I'm going to talk about atomic radius. The atomic radius of an atom is the distance from the nucleus of the atom to the average position of the outermost electron. So if you imagine those electrons don't have from a quantum mechanical sense, don't have a fixed position, or if you want to sort of think about it from a Bohr-Rutherford perspective, they're flying around out there. So if they're flying around out there, then they're not in the same spot all the time, so we can imagine they have an average position. If we found that average position, it's from the center, from the nucleus, so if it's like, plus 10 to the electron that's the furthest away, that's what we call the atomic radius. If we imagine this electron flying around in this thing, and then we think of the atom as a sphere, then the atomic radius is the radius of that sphere. So here's the answer, or here's the trend for the periodic table. What we can see is hydrogen and helium are very, very small. And then every time we start a new row, we get bigger. So this is a new shell, and this is a new shell, and this is, one shell, two shells, three shells, four shells. So we're adding a new shell each time we go down. And then as we go from left to right, we can see that these guys are getting smaller and smaller and smaller to the point where neon is very, very small again. This trend occurs for two basic reasons. One, the number of electron shells, and two, the effective nuclear charge. So for the effective nuclear charge, again, from our trends, we know that this has an effective nuclear charge of +1. This row has +2. This row has +2 all the way across until we hit +3, +4, +5, +6, +7, and +8. Now remember, effective nuclear charge is the amount that the nucleus is pulling the electrons in or sort of the amount of attraction. So what we can see when we go from left to right is that as the effective nuclear charge is getting higher, the electrons' attraction is getting higher, and as a result they're getting pulled in closer, so the atomic radius is getting smaller. So here we see lithium's quite large, low effective nuclear charge, and so those electrons aren't pulled in that tightly. Add more effective nuclear charge, +2, we get a smaller atom, all the way up to this guy, and his effective nuclear charge of +8, and those electrons are being pulled in quite tight to that atom. Then, starting a whole new shell, we start back over at the effective nuclear charge of +1 with sodium, and as a result the atom gets quite large due to the lack of attraction again. When we go from top to bottom, this trend is fairly straightforward. Every time we add a new shell, new shells are always larger, and so the atomic radius is getting larger. So here we say new shells are bigger. So when we go top to bottom, or this way, new shells are bigger, so the atomic radius gets bigger. Here when we go left to right, or this way, the effective nuclear charge is getting bigger. Meaning the atomic radius is getting smaller due to the increased attraction. 4 electrons to the nucleus. And so that's why we can see the two trends here. We can see cesium down here is going to be a pretty big atom as we go across, smaller, smaller, smaller. And so we go smaller and smaller with less and less shells. And that's how our atomic radius changes when we move around the periodic table.